There has been no civilization on Earth untouched by beliefs surrounding the moon. The moon has been an object of wonder and amazement for the common man over the centuries. At the same time, the scientists have been busy unraveling the mystery of the moon. How could Earth acquire such a large satellite? What is the moon's origin? What is the moon's chemical composition? Do we need to know these? Is it a body formed elsewhere in space and captured by the Earth in one of their close encounters? Or is it formed from the same cloud of dust and gas out of which Earth formed in the beginning, side by side? Or was it an outcome of a collision of a giant cosmic impactor on the Earth? Many other theories too are coming up. But what is the truth? Then there are many other questions. Do the two poles of the moon contain ice? Are there deposits of helium-3? Small amounts of it are capable of meeting all the power requirements on the Earth by nuclear fusion. And therefore, for the Indian space program, the moon is the next stepping stone. The year to embark on the moon mission will be 2007, but the tested and proven Polar Satellite Launch Vehicle, or PSLV, has already been identified as the preferred launch vehicle. The PSLV will be carrying the first Indian lunar craft, Chandryan-1. The lunar craft will be a cuboid of 1.5 meters using honeycomb sandwich cylinder technology for its main load-bearing elements. 3-axis stabilized lunar craft will use fiber optic gyro for accurate control. Adequate amount of bipropellant fuel will be carried by the lunar craft to be used for the mission life of various maneuvers and altitude maintenance in lunar orbit for 2 years. The PSLV will first place the lunar craft in a highly elliptic orbit around the Earth, identified as Elliptical Parking Orbit, or EPO. The closest point of the orbit to the Earth will be 240 kilometers, and the farthest 36,000 kilometers. Then the liquid motor will fire to take it away from the Earth's gravity. The lunar craft will travel over a period of 5.5 days, covering about 3,86,000 kilometers on the trans-lunar trajectory to arrive near the moon. Here, the lunar craft will be slowed down to allow its capture by lunar gravity and to put the lunar craft in the near-circular polar orbit at about 1,000 kilometers. In this 1,000-kilometer orbit, the solar panel of the lunar craft will be deployed. A series of in-plane corrections to reduce the height of the craft from the lunar surface will place it in the 200-kilometer near-circular orbit. After the performance check of the lunar craft and its orbit around the Moon for a week or two, the altitude will be further reduced to 100 kilometers to put the lunar craft in the final designated polar circular orbit. With the placing of the lunar craft in this orbit around the Moon, the study objectives of the mission will be initiated. For the next 2 years, the lunar craft will circle the Moon and collect remote sensing data, following a strategic plan of imaging of the different regions of the Moon. Let's look at the major mission objectives and the intended payloads to achieve them. The mission aims to obtain a high-resolution, three-dimensional atlas of the whole Moon with spatial and altitude resolution of 5 and 10 meters respectively. Since the fluorescence X-rays produced by various major elements present in moon rocks are excited by solar X-ray flux, the intensity of solar X-rays and their energy will be measured by X-ray monitors installed on the lunar craft, which will be viewing the Sun all the time. On the other hand, high-energy X-ray hex spectrometer will cover the 15 to 200 keV region. The mission would explore the entire lunar surface for various elements.